Hello guys, this is Neha. Welcome to my channel Guruaura. In this video we will discuss few problems related to relations. So, let's see our first question. Let set A contains the elements 1, 2, 3, 4, 5 and 6. Define a relation from set A to A by R is equal to x comma y such that y is equal to x plus 1. Then write down the domain, codomain and the range of R. So now let's see the answer. So putting x is equal to 1, 2, 3, 4, 5 and 6 respectively in the given relation y is equal to x plus 1, we get y is equal to these values. That is, y is equal to x plus 1. We need to do x plus 1. So 1 plus 1 will give us 2. 2 plus 1 will give us 3. Similarly, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6 and 6 plus 1 7. Clear? Now, for x is equal to 6, we get y is equal to 7. For x is equal to 6, we get 6 plus 1, that is y is equal to 7. But do 7 belongs to A? No, 7 does not belong to A. So, when we define a relation from set A to set A, we can't consider the element 7. So, we have this 5 ordered pairs 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. Hope you are clear till here. Now we need to write down the domain, codomain and range. So dear students, what's domain? The set of all first components of the ordered pair belonging to R. So what are the first components here? 1, 2, 3, 4 and 5. So the domain consists of these 5 elements. Now next, codomain. The whole set A. Hope you remember this. The whole set will be there in the codomain. So the codomain contains the elements 1, 2, 3, 4, 5 and 6. Now let's talk about range. So the set of all second components of the ordered pair belonging to R. Remember? So here the second components are 2, 3, 4, 5 and 6. So the set of range will consist of these 5 elements. Clear till here? So now let's see the next question. Figure shows a relation R between the sets P and Q. This is the set P. Set P contains the elements 9, 4 and 25. And set Q contains the elements 5, 3, 2, 1, -2, -3 and -5. And this figure shows a relation between these two sets. Can you say this? Now, write this relation in the roster form and set builder form. And next, what is its domain and range? So students, hope you remember what's roster form and set builder form. We have already discussed in the first chapter, that is the sets. Roster form, a set is described by listing the elements separated by commas. And in the set builder form, a set is described by characterizing the property of its elements. So yeah, I have given a hint. Now let's pause the video and try to solve the problem and play the video again to see if you have got the right answer. Now let's see the solution. So yeah, roster form, a set is described by listing the elements separated by commas within the bracket. So here, what are the elements? 9, 3. Here, the element 9 is linked with the two elements of set Q, 3 and -3, shown by the yellow arrows. Next, the element 4 of set P is linked with the two elements 2 and -2, shown by the blue arrows. Clear? And then the element 25 of set P is linked with the elements 5 and minus 5 of set Q. So we have these 6 ordered pairs as the elements of the set R. Now let's talk about the set builder form. A set is described by characterizing the property of its elements. Can you see any property of the elements? Here, the element 3 and the element 9. Can you see any characteristics between these two elements? Yeah, x is equal to y square. So how can we write this using the set builder form? X comma y such that x is equal to y square. Here x belongs to set P and y belongs to set Q. Hope you are clear till here. Now let's see what's the domain and range. Domain, the set of all the first components. You can see here 9, 4 and 25. As these are the first components, this will be under the set of domain. And range. Now the range will consist of the second components 3, minus 3, 2, minus 2, 5 and minus 5. This 6 elements will be there in the set of range. Clear? Now let's see another question. Set A and B. Let set A contains the elements x, y and z and set B contains the elements 1 and 2. Find the number of relations from A to B. So you need to write the number of relations from A to B. So yes, let's now answer this question. So yeah, we have already learned in Cartesian product how to do A cross B. Yes, so A cross B will contain 6 elements and ordered pairs as the elements. So the first ordered pair is x comma 1, next x comma 2, then y comma 1, y comma 2, z comma 1 and z comma 2. These are the 6 ordered pairs. Okay, so n of A cross B contains of these 6 elements. Now the number of subsets of A cross B is 2 to the power 6. Thus the number of relations from A to B is 2 to the power 6. Hope you are clear with this. Now let's see the next question. Write the relation R is equal to x comma x cube such that x is a prime number less than 10 in roster form. So yeah, now students, let's pause the video and try to solve the problem and play the video again to see if you have got the right answer. So yeah, now let's see the solution. Prime numbers. Hope you remember what are prime numbers. So the prime numbers less than 10 are 2, 3, 5 and 7. So what's the relation? X comma x cube. So what you need to do? 2 comma 2 cube, 3 comma 3 cube, 5 comma 5 cube and 7 comma 7 cube. So what's 2 cube? 8, 3 cube 27, 5 cube 125 and what's 7 cube? 343. So the relation contains these 4 ordered pairs as its elements. Hence R is equal to 2 comma 8, 3 comma 27, 5 comma 125 and 7 comma 343. Okay, now let's come to a different question. Here set A contains the elements 1, 2, 3 and 5 and set B contains the elements 4, 6 and 9. You need to define a relation R from A to B by R is equal to x comma y. The difference between x and y is odd. Okay, and x belongs to A and y belongs to B. And write R in roster form. So yeah, now let's try to solve this. Okay, So set A contains the elements 1, 2, 3 and 5 and set B contains the elements 4, 6, 9. So the difference between X and Y is odd. So here if we do 4 minus 1, if we take 4 and we do 4 minus 1, we'll get 3. And yes, 3 is an odd number. Next, if we do 6 minus 1, we will get 5. And yes, 5 is an odd number. Next, if we do 9 minus 1, we will get 8. But 8 is an even number. Okay? So we consider this ordered pairs 1, 4 and 1, 6. Clear? Now, let's check with the element 2 of set A and the element 4, 6, 9 of set B. Fine. So 4 minus 2 will give you 2, 6 minus 2 will give you 4 and 9 minus 2 will give you 7. Here you can see 7, an odd number. So we will consider only this ordered pair 2, 9. Clear? Similarly, if we take the third element of set A and these 3 elements of set B, and if you check for this, we will get 4 minus 3, 1, an odd number. 6 minus 3, 3, an odd number. 9 minus 3 is equal to 6, an even number. So we can't consider these ordered pairs. So here we will consider 2 ordered pairs that are 3, 4 and 3, 6. Clear? Now, yeah, similarly for this last element 5, if we link with 4, 6, 9, we get odd, odd and even. So the elements are 5, 4 and 5, 6. Hope you are clear with this. So dear students, this brings us to the end of this video. If you have any more questions or stuck with a problem, go visit my website guruaura.com and post your questions. I will be happy to answer your questions. In our next video, we will learn about functions. Hit that like button if you like my video and don't forget to subscribe and share. Thank you.